I'm going to go through these big ideas. I don't have a lot of time, so I'm going to focus mainly. I decided to pick on common fractions. I'm going to touch on this, and I will look briefly at 2D shapes as the session closes. And I've just got a couple of points to make about the other two there. This is a nice little diagram that Calvin put together. Essentially, it shows you the flow. So from K, developing deep understanding of whole number. Year 1, they start on common fractions, and when we get to when we get to year 5, we can start on decimal fractions. Now, why is that? Well, decimal fractions, as it tells us, decimal fractions is alike whole numbers in what way? If you have a deep understanding of that, once you have a deep understanding of that, it's a nice progression into this because it's similar to whole numbers in that there's places, right? It has place value, tenths, hundredths, thousands. And it's similar to fractions in that they describe parts of a whole. So it makes sense to me that you develop a deep understanding of whole numbers and common fractions before you start decimals, which we haven't done in the past. So if you just look at whole numbers first of all, this is essentially what's happening. So the prepping teacher, we have prep teachers here, right? If you turn to page, in your document, you'll see that the K on page 8, and it'll mention it in a couple of different places. Under numeration, so halfway down your first column, numeration, it talks about knowing numbers to 10. And they have to do that well. But in other places, like directly above that little section of numeration, it talks about numbers to 19. And in counting, the main heading at the top of that column refers to counting to 20. So numeration to 10, but working with numbers to 20 in the prep. In year 1, numbers to 100. In year 2, numbers to 1,000. Let's just look at year 2 on page 13. Under numeration, it's almost halfway down the page. You might have to highlight that. Year 2, 15, page 15. It says recognise, model, and represent numbers to 130. Right. But further down the page, under place values, there's no numbers to 1,000. And when they're asked why in a meeting, because as certain people are invited to these meetings and when the draft process was happening, when they're asked why 130, the response was, I don't really know. Okay, so Steve Nisbet of Griffith University, he actually asked that question. Why 130 here and why 1,000 there? And they weren't really able to tell us. Okay, so I suspect that when this comes out in the final draft, that number's going to be changed, and there's going to be numbers to 1,000. Okay. Year 3, it consolidates numbers to 1,000 and goes beyond 1,000. And we'd really need to do that, wouldn't it, in order to start getting kids from 1,000 to 1,000,000 in grade 4. Am I scaring some of you? I mean, in principle, I think they're great ideas. They're good changes. It's just what I would think some inconsistencies are here. And all whole number appears in these 4 different content description headings. So if you looked at grade 2 or 3, you'll see whole number under counting, you'll see it under numeration, you see it under place value, and you see it under number patterns. So the types of things you might be doing in year 4 under number patterns, I have not looked at this, but I suspect is that in the patterning of hundreds, tens, ones in the places. So they probably need to really go to 9 digits to look at that pattern. Decimal fractions, I've probably already alluded to this. You won't find these statements in there, I've just summarised them. We're basically establishing tenths in year 5 and hundredths, and in year 6 they go to thousands. Alright. Common fractions actually start in grade 1. I've started there in year 2, all the way up to into year 5. So this is most important. The 3 different models are used and needed in order to achieve what's in here. And what I'll do is I'll pick year 4 and we'll focus on that in more depth. And then we do the related denominators and eventually the unrelated denominators in year 6. These are the two. I'll look at year 4 under common fractions. So if you turn to year 4, it starts on page 27, but these two headings don't appear until pages 29 and 30. So if you want to highlight that, this will be something you can take back and talk to your teachers about. This is where some major changes are occurring. So they're the two statements. That one appears under fractions on page 29, and this one appears on page 30 under counting fractions. Basically, I want to look at a lot of the key elaborations that appear on page 29 in that left-hand column, and also some of them appear on page 30. In order to achieve these elaborations, I mean things like demonstrating equivalence of fractions, such as on a number line, or recognising that the relative size of a fraction is dependent upon the size of the whole. You have to have a pretty good understanding of the types of models that we use to teach fractions. Traditionally, I was about to say in Queensland, that's not quite true. Traditionally, I would say in Australia even, we use one model for showing fractions. What model would that be? I mean, the previous slide, I think, showed these are the three models: a set, as in a three-dimensional model, an area model, or a length model. What's the model we tend to use a lot of? Well, we do a little bit of the set. It's really, we use a lot of the area model. And really, I think it's the length model, this model, the one-dimensional model, is probably the most useful to achieve what's in here. And I'll show you that. So if you have a road or you could have a fence, the fence is 10 metres long, you divide it in half. You know, how long is that? Half. First of all, we call it a half. You have a line, you're dividing into so many equal parts, you divide it into 4 equal parts. What do you call each part? And 4 equal parts are called, by the way, they do call it here 1/4. They don't use the word fourth, not to suggest that you wouldn't use the word fourth. I would be, but I'm just saying they refer to it as quarter in here. There's the area model, two-dimensional. That's a real-world picture of it. That's really a classroom picture of it. So you're dividing into so many parts. In this case, it's 4 equal parts again. And the last one is a set model, a three-dimensional model. And that's a classroom picture. You divide it into, in this case, divided into there's 6 parts there. This illustration suggesting that I've made it divided into 3 equal parts. How many in each part? The problem with the set model, and this is why I've got it here, is to determine what's one whole. What is one whole? You can see it. We can see it easily with a different model. This one's a little bit more difficult, and this is why we've used this illustration here, because a carton tells you what the whole is. This is a hybrid, if you like, a hybrid model. This is a cross between the length model and the area model, right? It's essentially like a number track. And one of the positives or advantages of the length model is you can go easily beyond 1. If I use that set model of the eggs to go beyond 1, I just need more cartons of eggs. And you start seeing where is one whole. We've sort of lost the picture of where one whole is again, right? So it has that advantage. It's also very good for operating the length model. You take this example. What's the number one answer for that? What do children say the answer is? What's the number one answer?
11 over 20.
Very good, 11 over 20. Which, as you know, is wrong. But if you use a number line model or length model, it's quite easy to show why that is wrong. Where is 7/10? That's here. I want to add to it 4 more tenths. So what is that? It's really like a jump of the 7 from the 0 and another jump of 4. And what is that? It's 11/10. Clearly shows why it's not 11/20. This is one of the elaborations. If you look on page, I think it's on page 30, halfway down, you might want to highlight it. It says counting forwards and backwards by familiar fractions, halves, quarters, thirds, fifths and tenths. So again, because you can show more than one, it's nice to be able to, you can count the wholes, but you can also come back here and count the parts. So that's what they're expecting you to do. is when you do that, it also, you can satisfy this other elaboration, converting mixed numbers to improper fractions in the reverse. So here we have proper fractions, right, such as 3/5, and over here we have the improper fractions, such as 8/5. But if I wanted to convert this, 8/5 is the same as 1 and 3/5. Okay. What other elaborations do we have here that are worthwhile looking at? Demonstrating, that's on the previous page, back to page 29 you might look at. Demonstrating equivalence of fractions such as, on a number line. So we can divide the number line into fractional parts. Then we might decide, let's go back and divide it into more fractional parts. What else do we do? Divide each quarter into a half again, put some more increments in there, and mark this in, which then helps us to see the equivalent fraction. 1/4 or 1/4 is the same as 2/8, or 3/4 is the same as 6/8. We tend to do that, don't we, on what you would call a fraction wall, which is again a hybrid between a length model and an area model. But this is talking about such as on a number line. So if you do it on a number line, that's what you'd expect to see. This is the point down on the very bottom of page 29. Well, not the very bottom, sorry, it's the second last one if you like. Recognising the relative size of fractions depending upon the size of the whole. You can see 3 oranges and you can see 3 apples. Now, is 3 the same in those particular two cases? No, well, no, they're not. There's 3 apples and there's 3 oranges. But the idea of 3 is still there, right? The same with here. 1/4 happens to be greater than 1/2 in this particular case. They have to know that the idea of 1/2 doesn't change. And that's what they're trying to get to here. If you look at the example they use, I kind of like this example here. You know, the thirds of a netball court are smaller areas than thirds of a football field. That's like I was comparing here apples to oranges, saying 3 apples, 3 oranges. Well, here they're comparing thirds. Okay, so this third might be bigger than that third, as you know, but it's the idea of a third does not change. And directly above that elaboration is calculating everyday fractions of quantities. So this is where now they're going to start operating with fractions. And how do they do that? 1/4 of 24 is. So they're using unit fractions, but 1/4 of 24. How do you figure out 1/4 of 24? You're going to use division, aren't you? I know 1/4 of 24 is, well, you show it like this. Here's the 24. There's 24 dots, there's 4 equal rows. How many in each row? In other words, I know 1/4 of 24 is 6. I know there's 6 in each row because I know 6 fours are 24. So you're using these prerequisites here. This is most important. You have to have this in order to do that. I don't particularly think that's too difficult. I think that, you know, if you're focusing, if there's time allocated just to doing that, you'll be able to teach that. So my concern is, and it's concern for some of the writers or the people in charge was, and actually they went as far as saying teachers are going to have to let go of their pet activity. If they have pet activities for teaching tenths in year 4, they're just going to have to let it go and allow it to be taught in year 5, because if you're still trying to teach that in year 4, you won't have the time required to give a deep understanding of whole numbers.